Next topic we're going to cover is on something called scientific notation, or what most students call this video is, Mr. Schmidt, why did we have to learn negative exponents? Because I tell you that everything we learn in middle school math is usable in the real world, and even negative exponents get used in the real world a ton. And I really like this section because it's one of the opportunities where we get to mix science and math class together. So let's get started with it right away. The world is filled with extremely large and extremely small numbers, and the example that I like to think of is the number Google. In fact, it's actually written as a number like that, a Google. The reason why you can always remember that is if you look at the bottom of a Google page, it adds all these zeros in here. And the reason why they do that is a Google is actually the number 1 followed by 100 zeros. So if you were actually trying to write the number Google, it would be basically impossible to do that and fill it in on any page. So what we do is a topic called scientific notation. And the number Google is written like this, which simply means the number 1 followed by 100 zeros. So when we go to scientific notation, I'm hoping it's one of those topics we can always remember why we use it, because of Google. So let's start actually looking at what scientific notation looks like. Scientific notation is broken up into 3 main parts. The first part is always a number in front of the decimal point, and this number must be 1 through 9. So if we picked the number, let's say 3, it's between 1 and 9. Now technically, this can be anything less than 10, so it's a little bit more accurate to say between 1 and 10, but just remember that it can't be 10 or more. Then it's followed by any number behind the decimal point. So I'm going to let's do 8, 9. Okay, so this is 3 and 89 hundredths. Now, I try really carefully, I try to be really careful when it comes to saying decimals correctly. Scientific notation is the time when I stop being really careful. I'm okay if you say 3.89 at this point because of scientific notation. These numbers get ugly really fast. So then it's times 10 raised to the, and you pick a exponent. So let's start with a positive exponent. Let's make this 4. So what this actually means is we have the number 3 and 89 hundredths times 10 to the 4th power, which is simply 10,000. Now, if you notice there's an X here for multiplication, that's because this is now a science topic. So as a math teacher, I use a dot, but all science teachers are going to use an X. You can use either. So if we had the number 3 and 89 hundredths times 10,000, we're actually going to be moving the decimal point to the right 4 times. So scientific notation is a shortcut. So what we do is we take the number 3 and 89 hundredths, and because we're multiplying it times 10,000, we go 1, 2, 3, 4. Decimal point's now here, and these numbers are now zeros. So this ends up being the same thing as this number. 38,900 is the same as 3.89 times 10 to the 4th. So positive exponents mean big numbers. So negative exponents, we know from the last part, actually mean fractions, but in our case of scientific notations, they actually mean little numbers. So let's keep everything about this problem the same, except let's change our exponent to be a negative, let's say 5th. So what that means is we're actually multiplying times 1 over 100,000. Well, if we're dividing by 100,000, the decimal point's going to go left because we're making a smaller number, and it's going to go left 5 times. So we write out our 389. We go left 5. 1, 2, 3, 4, 5. We add in zeros, and we put our decimal point right out here. So we have this number, which is really difficult to say. So in this case, I would say 0.0000389. Okay? Now notice that it's 10 to the negative 5th, but it doesn't have 5 zeros. You have to count the process out and be very cautious with it. But this is the part that you need to know. Positive exponents mean big numbers. Negative exponents mean little numbers. So let's look at some of these in actuality. We have this number out here, which is really big. If we wanted to actually learn how to say this correctly, thousands, millions, billions. So this is 33,500,000,000. Huge number, right? It's just like my bank account. So when I am going to write this as scientific notation, once again, we always write with the first number, then followed by something, times 10 to something. Okay? Well, the first number has to be between 1 and 10. So I'm going to put the decimal right there, and that gives me a 3. If I put the decimal here, it creates 33. Doesn't work. If I put the decimal here, the number is smaller than 1. Also doesn't work. So I fill in the rest of the numbers, ignoring all of the zeros. So 3, 5. So it's 3.35. And now my question is, how many times did I move the decimal? So I go 1, 4, 7, 10. So the question becomes, is this a positive exponent or a negative exponent? Well, this is a big number, therefore it should be a positive exponent. And we're done. That's it. So let's go down to something with a small number. This will be a negative exponent. Once again, I'm going to put the decimal right here because I need it to be between 1 and 10. So I have 6 and 2/10 times 10 to the negative something. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So this will be 6.2 times 10 to the negative 8th power. And that is it for scientific notation. Everything we cover past this point is simply expanding on what I showed you right here. Let's do a couple real-world examples of why we're actually going to use scientific notation. One of my favorite topics, obviously, is space. And one of the topics in space is how far can light travel in a year? A light year. A light year is actually written by this number, which is 5.879 times 10 to the 12th miles. Well, if I was going to write this out as a regular notation number, it would be this, followed by 1, 2, 3, and then 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I'm hoping at this point you realize that writing this out as a regular number is crazy difficult. Therefore, writing as scientific notation would be much easier. Another example of this would be the mass of an electron. An electron is a part of an atom with a negative charge. So an atom, very, 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 very small. An electron, even smaller. Sometimes you'll see these exponents written like this. This caret means exponent, or e to the negative 31. So we would write this number as 9 and 1/10 times 10 to the negative 31 kilograms, which is barely anything, absolutely minuscule. And I'm not even going to write this out because it's going to be 30 zeros, which is intense. Let's do one last example, which we're not actually going to cover in full weight, but an example of something that you could see as a real-world problem. This is something that could show up in science class, and it's asking you to take this number on top and divide by this number on bottom. And you are lucky because if you watch to this part of the video, you may use a calculator. And what I would like you to do is come up and work with me on some of these calculator problems when you see them. But what I want you to do is I want you to turn these two numbers into standard notation, okay? So this top number will be 7 zeros and then 3, 4, 3, 2. Because if the decimal was here, it would be 8 left. So that's our first number on the top. And on the bottom, it will be 4, 2, 1, and then 4 zeros because we have to move the decimal 6 from here. Once I have this, I am going to pull up a calculator, and we are going to type out what we just had on a calculator, which is, the first number is 7 zeros. So 1, 2, 3, 4, 5, 6, 7, and then 3, 4, 3, 2. And our second number will be 421 with 4 zeros. And we type that in, and it gives us this crazy number. So what we're going to do here is we're actually going to round to the hundredths place, because I always like to round to 2 decimal places. We're going to ignore the rest. This e means times 10 to the negative 15th power. So if we go back here, that means our answer is 8.15 times 10 to the negative 15th. And remember that the calculator has e negative 15. These mean the same thing. So, as always, if you have any questions, make sure you let me know. I'm hoping that you enjoy scientific notation because there's a lot that you can actually do with it, not just in math class.